All right, so the next key features that we're going to talk about are intercepts, both x and y intercepts, and then something called multiplicity, which we did not really go over when we did that video on all the key features, so I'll explain what that is also. So x-intercepts and y-intercepts, to algebraically find the x-intercepts, an x-intercept, that's where y equals 0. So your first step is going to be to plug 0 in for y. Or remember, f of x is really y. Okay, so then once you have 0 in there, you're going to solve that equation, and you can either do factoring, or if it's a quadratic, you could do completing the square, or you could also do quadratic formula. But you're mainly going to stick to trying to factor. Okay, you get your answers. And then lastly, with intercepts, you have to write your answers as points or coordinates. And those answers are going to be whatever number you get, comma 0 for the y value, because again, x-intercepts are where y equals 0. To algebraically find the y-intercept, you're going to do the same thing. It's just a little bit less work. To find the y-intercept, first you are going to plug 0 in for x. And then you're not going to solve anything because it's different when you plug in for x. You're going to just evaluate. So you're going to actually get a number. You evaluate, and then lastly, you're going to write it as a point. So that would be 0 for x, and then whatever number you get for the y value. So if we look at these first two examples down here, we are going to find all of the intercepts to each of them. So that includes both x and y intercepts. So if we look at this first one, let's do x-intercepts first. X-intercepts are where y equals 0. So I'm going to do 0 equals 3x squared times x minus 2 times x squared minus 4. And then I'm just going to factor this further. So I have 0 equals 3x squared times x minus 2. X squared minus 4 is x plus 2, x minus 2. And then now I'm just going to set them equal to 0. So 3x squared equals 0. That'll give me x equals 0. X minus 2 equals 0. Gives me x equals 2. X minus 2 equals 0 again gives me x equals 2. So you don't have to do that one twice. And then x plus 2 equals 0 gives me x equals negative 2. These right here, these are called the roots or the zeros. X equals 0, x equals 2, and x equals negative 2. The roots or the zeros, that's where where the graph hits the x-axis when your function equals 0. To then make them x-intercepts, you're going to write them as the points. So this first one's going to be 0, 0, 2, 0. I'm not going to write 2, 0 again, and then we also have negative 2, 0. So that's how to algebraically find the x-intercepts. So I'm going to do the y here, and then I'm going to erase it for when we do number 2. So my y-intercepts now, again, this is still for number 1. Y-intercepts are easier because y-intercepts are where x equals 0. So I'm going to do f of 0 equals 3 times 0 squared times 0 minus 2 times 0 squared minus 4. And you can type that entire thing into your calculator, and you're going to get f of 0 equals 0. So this one has a y-intercept at 0, 0. Okay, so that's all of your intercepts for number 1. So I'll pause the video if you have to. I'm now going to erase this. That way we can do number 2. Okay, so for number 2, we're going to do x-intercepts, and we're also going to do y-intercepts. So again, x-intercepts are where y equals 0. So I have 0 equals 6x squared plus 28x minus 10. So I'm going to solve this. I'm going to factor it. So 0 equals, my GCF would be 2, and I'm left with 3x squared plus 14x minus 5. I need two numbers that multiply to be negative 15 and add to be a positive 14. So it's going to be plus 15x minus 1x minus 5. So I have to split it down the middle. I have 3x times x plus 5. And on the other side, negative 1, x plus 5. So x plus 5 comes out. And I still have 3x minus 1. And then we had our GCF of 3. So when I take each one, set it equal to 0, this 3 equals 0. That makes no sense. You're going to cross that out. X plus 8 equals 0. Sorry, the x plus 5 equals 0. And then 3x minus 1 equals 0. So this gives me x equals negative 5, giving me my first x-intercept at negative 5 comma 0. And then over here, this gives me x equals 1/3. So we have 1/3 comma 0. And those are my two x-intercepts. Now for my y-intercept, that's where x equals 0. So I'm going to do f of 0, 6 times 0 squared, plus 28 times 0 minus 10. F of 0 is negative 10, so I have a y-intercept at 0 comma negative 10. Okay, so we have x-intercepts and y-intercepts. Make sure you answer all of the intercepts. You don't just do the x. All right, so moving on to multiplicity. Multiplicity is the multiplicity of a root is the number of occurrences of the root in the complete factorization of the polynomial. It's how many times you get that root. So before we got x equals 2 twice. So whenever you have an odd multiplicity, your graph will cross the x-axis at that root. Whenever you have an even multiplicity, your graph will be tangent to the x-axis at that root. Okay, so we have even is tangent, odd will cross. So for number 3, we're going to look at these two functions, the same ones that we just did because we just factored them completely. So you have them in your notes what they were when they were completely factored. So number 3, when we completely factored this, right, we had this ended up turning into f of x equals 3x squared times x minus 2 times x minus 2 times x plus 2. Right, that's what we did a second ago when we were finding the x-intercepts. So we are actually, before we do the multiplicity, we're going to look and see if we have any repeaters. So we have 3x squared. X minus 2 happens twice, so we're going to write that as x minus 2 squared and then x plus 2. So 3x squared gave me the root x equals 0. So this is coming from 3x to the second power. So because we have two factors that give me x, right? You have x and x to give you x squared. Because you have two factors that give you the root x equals 0, that multiplicity is even, which means your graph will be tangent to the x-axis there. X minus 2 squared, that gave you the root x equals positive 2. That is also coming from x minus 2 to the second. So because you have an even exponent, the multiplicity is even. It's happening twice. So because it's happening twice, it's also going to be tangent. The last one, x plus 2 to the first, right? There's no number there, so that's a 1. 1 is, well, this gives you x equals -2. 1 is odd, so the graph is going to cross the x-axis at that point. So what this graph is going to look like, I'm just going to show you a quick sketch of it. We have -2 is over here. This is obviously 0. And then we have +2, we'll say, is over here. Your graph, this is where it hits the x-axis, right? These are your roots. Is going to be tangent at 0 and 2, and it's going to cross at -2. So this is what it looks like if you like sketch it quickly in your calculator. You're going to cross through at, whoops, that should actually be crossing. You're going to cross through at -2. There we go. And then you're going to be tangent at 0. So what it means to be tangent, it's like you're bouncing off of the x-axis. So you come up, hit the x-axis, and then come back the way that you came. And then same thing with 2. We're also tangent at 2, so we come up, hit the x-axis, and then come back the way that we came. And this is what your graph looks like. So at -2, it crosses right on through, but at 0, it's tangent, and at 2, it's tangent. Okay, let's look at number 4. So again, number 4 is like number 2. So when we completely factored number 2, this looked like this. We had f of x equals, there was a GCF of 2, and then this ended up being, I think it was x and 5 and 3x and 1. It was 2 times x plus 5 times 3x minus 1. So there's no repeating factors here. So this one gave me x equals -5, and this one gave me x equals 1/3. So x equals -5 came from x plus 5 to the first power. 1 is odd, so it will cross. Same thing over here. X equals 1/3 came from 3x minus 1 to the first. 1 is odd, it will cross. If you look at the graph of this function, this will be -5. This will be 1/3. They both cross right on through. They're not tangent at all. So it really goes down and then comes up. Only time it touches the x-axis are at the 2 roots. All right, and then the last thing we're going to do quickly is when you can't factor something, the way that you're going to find your x-intercepts and y-intercepts is using the calculator. So take out your calculators. And these are your steps. To graphically find the x-intercepts, you are going to plug the equation into y equals. Then you're going to press second, trace, and x-intercepts is number 2. It says zeros. Remember, another name kind of for the x-intercepts are your zeros. Just like with the extrema, it's going to ask you about left bound, then it'll ask you about right bound, and then it'll say guess. Left bound, right bound, and then it'll say guess, and then your last step, just like before, is going to be to write, step 6, is going to be to write it as a point, as a coordinate. To graphically find the y-intercept, same deal, you're going to plug into y equals. Then your second step, you're going to press second, trace, and you're going to choose option number 1. It says value. We want the value when x equals 0. So that's your third step. You're going to press 0 and then enter. And then lastly, you're going to write your answer as a coordinate or a point. Okay, so let me just show you quick how to do this in your calculator. This last example down here, we have 2x to the third plus 5x squared minus 4x minus 7. I already have that typed into y equals. Then I look at my graph, right? So I'm just going to draw a quick sketch over here of what that looked like. And it was something kind of like this. Okay, so it was actually a little bit over, but that's okay. So we have 3x intercepts, and we have 1 y-intercept. You're always going to have only 1 y-intercept. So in your calculator, you are going to press second, trace, number 2. So we're looking for this point right here. I'm going to go in order. So this is as close as I can get to the actual intercept. It's asking me to be left bound. So if I move to the left side, I'm actually going to be below the function. Press enter. Right bound, I'm going to switch. Now I'm above the function. Press enter. Guess. Enter. And that is your 0. Negative 2.766. And then 1e negative 12. Whenever you have e, that's going to be 0, which makes sense, right? Because our y values should be 0 for this. So we're going to round to the nearest hundredth. That should be in your directions. Nearest hundredth. So my x-intercept, again, was negative 2.77, 0. That's a decimal, not a comma. Now we're going to do it all over again to find the second one. So we're going to press second, trace, number 2 again. So now this is the point that I'm looking for, right? I'm going to be on the left side of it, which is actually above the function. Enter, right bound. So now the right side of it's going to be below. Enter, guess, enter. This 0 is nice and clean. This one's negative 1, 0. And then the last one, second, trace, number 2 again. I move my cursor. To be on the left side of it, I'm going to be below the x-axis. Right bound, then we'll be on top of it. Don't go too far that you can't see the cursor anymore. And then this one is 1.27, 0. Y-intercepts are easier. Y-intercepts, you're going to press second, trace. Number 1 is value. We want the value when x equals 0. Enter. Your y-intercept is 0, negative 7. Which makes sense because if I plug 0 into all the x values of that function, I would be left with just the minus 7 on the end. Okay, I know this is a lot of stuff, so we're totally going to practice this the next time I see you guys in class. Have a great day.